Hello, and welcome to this Sharpa Engineering presentation video. Our goal is to help you modeling and simulating your system over its whole life cycle. Today, we'll be introducing one of our benchmarking platforms, the Jaguar IPACE Thermal Management Simulation Platform. This platform accurately represents the IPACE's architecture, is a productive tool, is easy to use, is faster than real-time, gives highly accurate results, and comes with scenario definition capabilities. Now let's have a look at the platform's interface. As can be seen here, the platform is currently running, and at a pace faster than real-time. The upper part of the interface is dedicated to environmental conditions and system parameters. Here, we can observe or set some of the system's parameters related to environment, air conditioning, heat pump, and water loop systems. Let's have a look at the other tabs. The next one depicts the heat pump in more detail, along with its relevant environmental conditions and system parameters. The next one is a zoom of sorts on the water management system. It gives a more detailed view of this model's three different water circuits. Next to the Water Management tab, we have the Battery Cooling tab. This panel allows the user to understand the current condition of the battery system at a glance. Relevant information such as the current state of charge and coolant flow parameters are displayed here. Another thing to note is that powertrain as well as quick charge models can be taken into account during battery power calculations. We also have a dedicated tab for the current cabin conditions, which comes with its dedicated finger model for dissatisfaction percentage prediction. A plot of cabin temperature over time can also be found here. And last but not least, we have the Energy Management panel. It comes with three different graphs that reflect the system's current state, which we can control as follows. Until now, the platform was running using predefined scenarios. These values can be overridden by ticking the box next to the value we want to override, like this. The same can be done using control parameters such as valve opening parameters. Here, 0 refers to a closed valve, while 1 refers to an open one. Values in the middle can be used to quantify how widely open the valve currently is. As you can see in the cooling graph, this had a direct influence on how the calculations are going. These parameter changes were directly taken into account by the simulation, and we're able to see the system's response in real time. These parameters can be set independently of each other and at any time. Now let's have a look at the model's architecture in MATLAB Simulink. Our first layer contains plant model, control model, sensors, post-treatment tools, HMI parameters, and scenario definition tools. By double-clicking on the plant box, we end up in the architecture layer, which represents how whole systems can interact with each other. And by double-clicking on one of these systems, we enter the subsystem layer, which has been developed using our own FISIM tools. They feature high accuracy, especially after component calibration. Component calibration was done by tweaking model parameters until the simulation was able to accurately replicate data from real test benches. As you can see, our method allowed the platform to truthfully replicate component behavior even during transient modes. After calibrating all relevant components, cabin temperature difference with experimental data was less than 1.5 degree. All of this while giving results much faster than real benchmarks. Validation was carried out using standard WLTC 4-hour tests with various environmental conditions, ranging from -10 to 45 degrees. For each single one of these, similar levels of accuracy were achieved for all scenarios regarding battery cooling system and cabin temperature. We can provide three different types of services regarding this platform. The first one gives access to this benchmarking platform and comes with basic training on how to use it. The second one is a customized one. Not only do we provide access and training, but we also can help you adapting the simulator's architecture to your own needs. And lastly, our most in-depth offer aims to make you able to use, modify, and create your own models using Simulink and our FISIM modeling libraries. This would make you able to become autonomous in using and modifying simulation platforms such as this one. For more information, please feel free to contact us at commercial@sherpa-eng.com.